Hello everyone, welcome back to my channel. So today we're going to solve the binary search. And we're given an array of integers nums, which are going to be sorted in ascending order. And we are also given an integer target that we should look for. So if the target exists in the array, we will return the index of it. If it does not exist, we will just return the -1. So our goal is to write an efficient algorithm that can run in log n time. So what algorithm are we going to write? The title just told us that the binary search, right? It's the most intuitive solution for the array that is sorted. So it's a very important problem because many interview problems or the variations of binary search and could be much harder. And we need to implement the binary search as quickly as possible so that we can come up with solutions with harder questions in interviews. Okay, so we will use the binary search to solve this problem. The input array is sorted, we know that. And we have the target, which is 9. So the target value could exist anywhere in this array, or it might not exist at all. So when we start, we're considering the entire array. How are we going to do this? So we will have 2 pointers. The left pointer initially points to the leftmost element of the array, which is -1. And the right pointer initially points to the rightmost element, which is 12. So if we could only look at one element in the array for a single process, which element should we look at? The leftmost one or the rightmost one or any other element in the array? So imagine we look at the leftmost one, which is the -1, to compare it with the target. It's not equal, so we will eliminate just one element. And similarly for the rightmost one, we will just only eliminate one element as a single process. So it's not efficient as log n. It's just like look at every element in the array. What if we consider the midway element? Will we just eliminate one element if the midway is not equal to the target? No, right? Because we know that the array is sorted. When we consider the midway element, we should further ask, is it smaller than the target, or is it bigger or larger than the target? In this case, this is 3. It's smaller than 9 as it's sorted, so everything to the left of 3 can be eliminated. So in this case, we eliminate all the left values in the array. Then we will just update the left pointer and calculate the midway pointer. Then repeat the process and compare the midway element with the target. 9 equals 9. So we will determine 9 exists in the array. Regarding the time complexity, basically the idea of binary search is to cut off one half of the array and keep another half to further explore whether there is a target value in the array. So imagine we have 16 elements in the array and follow the idea that cut off the half, and we will have 8, 4, 2, and finally get the base case of 1. If we have a while loop to do this, the while loop is going to run as many times as we divide the length of the input array by 2. So mathematically, we will do this by using the log base 2n to calculate this. So the complexity of the binary search will be log n instead of n. Okay, so let's code it up. Like what I did in the drawing, we will go through the entire array and have 2 pointers. And we will have left and right. And the left is going to be 0, and the right is going to be the length of nums and -1 to ensure the index is not out of bound. We want to continue going until there is no more possibilities left, or we have maybe found the result. So the way to do that is basically say that while the left is smaller equal than the right. This is not said in the drawing that imagine we have a very small array, like the 1, and the target is 2. So the left and the right are all 0. First thing we want to do in every iteration of the loop is to find the mid. So the mid is the left plus right and divided by 2. So in this case, the num's mid will be the 1, right? It's smaller than the target. So we want to update the left to be mid plus 1. Left will be 1. And 1 is larger than the right, which is 0. It means that the left crossed the right. That's how you know that we have no more values left to search. So that's why we use the left smaller than right. And equal means if there is one element in the array, we want to find if the mid is the target one. We don't want to skip that. Okay, so let's continue. We have got the mid, and similarly, we will do the same thing if the current midway number is larger than the target. We will just cut off all the possibilities on the right-hand side. The other cases will just be the midway number equals to the target. In this way, we'll just return the index of the target or the mid. There is typo here. I just delete the divide stuff when I deleted the comment. So after we run all the possibilities of the while loop and we didn't return any index, we will just return -1 to indicate that there is no target in the array. Two things to remember. So the first one is the first time I did this problem, I have a typo to narrow the search range by saying that the left is just mid and the right is just mid. In this case, there will be some typos leading to infinite loop. Another thing to be aware is that if the array is very large, say 2 to power 32, there may be some overflow corner cases. In this case, the left plus right will be overflow. The way to solve it is to calculate the mid by right minus left. That will be the distance between the left and right. And we will add this distance onto the left to replace initial one. We can run our solution. And if we use this one to update to mid, there will be a little bit slower, but we can ensure that the number will not be overflow.